Hello everybody, this is Mr. Longo, and in this video we are going to cover methods of proving triangles congruent. Now I have listed 6 possibilities here, but I'm going to let you know that only 5 of them actually work. But one of them is going to be used to introduce why one will and why one won't. So remember, when we have congruent triangles, we have 2 triangles that have corresponding parts that are congruent. So if you look at this example, this is just to show you the patterns of what we're looking for. Side, side, side doesn't mean 3 sides in one triangle. It means one side in this triangle corresponds with another side of a different triangle. This one would be the congruent part of another triangle. So each thing represents one triangle to another, not within one, but the pattern still works. So we have side, side, side. We have 3 side markings in a triangle. So one method of proving triangles congruent is by side, 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 but we're just going to abbreviate that as SSS. So when we start doing triangle proofs, we would just say SSS. We wouldn't say side, side, side. The second example would mean if you have 2 sides and an angle. Now, there are a couple of different ways you can arrange that pattern, but in order for side, angle, side to work, the angle must be where your 2 congruent sides meet. Okay, so we have this left side and this bottom side, and they are meeting at that angle that is marked. That would be the SAS, also known as the side, angle, side pattern. Very, very similar to the last one, except for if you had 2 angles and a side that's in between those 2 congruent angles, that would be the angle, side, angle pattern. Okay? Moving on to the next row, extremely similar to what we just did in the one above. However, the side is no longer in between your 2 congruent angles. So if you look at angle, side, angle, the side is in between the angles. If you have 2 angles and a side, you can still prove those triangles congruent, but it's by angle, angle, side instead of angle, side, angle. Now here's the thing. The reason it works is because we all know triangles add up to 180 degrees. So if these 2 angles are the same, we'll just pretend this guy is 50 and this guy is 100. This guy would be 50 and that guy would be 100. We have 150 degrees in each triangle. That means both of the top angles are going to be 30 degrees. So that's why that one works. But the next one, we have angle, side, side. And you have an angle and 2 sides, but the angle is not in between. So you want to say that it's angle, side, side, and then people get the giggles, but it actually doesn't work. If you were to draw 2 triangles with an angle, side, side pattern, you could potentially get different looking triangles. So that does not work. It's not because it spells ASS. Angle, side, side just straight up doesn't work. Unless it is a right angle. And that's what I'm leading up to. If you have, see, this is an angle, side, side pattern, but it works because of the Pythagorean theorem. So if you have a right angle and then this side and that side happen to be the same, we could say this is 4 and this is 5, this is 4 and this is 5. If we did the Pythagorean theorem, the left side is going to be the same for both. So when you have an angle, side, side pattern, if the angle is not 90 degrees, you cannot do it. But if it is, you can use hypotenuse leg. Okay? So we're just going to give you a couple examples here to try. What I want you to do is think about what can be marked without actually having it marked already. And I'll lead you through the first one. So anytime you have the side that is being shared by 2 triangles, you can put marks on it because that's going to be congruent because it's in both. If we were to split this apart, we would have BC here, And we would also still have BC in that one if we were to just cut that. So the length is going to be the same. It's actually called the reflexive property. So since it shows up in both triangles, you can mark it. So we see that you have a side here, another side here. This is going to be the side, side, side pattern. But what is congruent to ABC? So A is this angle off, so we're going to match that up with D. And from A, we skip the long way over 2 tick marks to B. So we have to go from D and skip over 2 tick marks to C. And then obviously we have to finish at B. All right? So why don't you pause the video and try the next 2 examples and see if you can handle those. Give them a shot. Okay, so for this one, if you were to look, we have vertical angles here. Again, just like number 1, we have to mark what isn't already marked. So vertical angles will always be congruent. So this is an angle, that's a side. Notice that the side is not between the angles, so this is the angle side pattern. A has no tick mark, E has no tick mark, so those match up. It goes to B, which has a single tick mark, that matches up with D. And finally, we finish at C. So if you have triangle EDC by angle side, you are correct. And for the last one, very similar to the first one, that side is shared in 2 triangles by the reflexive property. We have a right angle side pattern, so this does work by HL. And ABC should have matched up with ADC, and then that would be correct. Okay? So that's how you prove triangles congruent. And you're going to be using those in the very near future with different types of proofs. So anyway, this is Longo and I'm out. See you, bye.